This is Professor Gibson. Welcome to lecture on section or chapter 11, section 1. This section, it's almost like there's two completely different parts to it. The first part is there's a bunch of new terminology, like there always is in the beginning of a new chapter. And there are questions in the homework that are really just a matter of using the definitions on these terms. And then we finish that. And then there's three different types of there's statistics problems, okay? Kind of more like as you figure out, you do something. Okay, so first let's go through these definitions. When you get to these questions, really you're just going to have to refer to the definitions and learn them well enough to answer the questions. All right, so let's begin with it. Data, you see any of the bold term in each sentence or paragraph is the definition, is the new term, the bold word or words. Data are measurements or observations that are gathered for an event under study. Okay. Statistics is the branch of mathematics that involves collecting, organizing, summarizing, and presenting data as well as drawing inferences from data. An inference is a conclusion reached on the basis of evidence and reasoning. Okay, so some more terminology here coming up. So a population consists of all the subjects under study. For example, all college students in the US would be a population. Another one might be everyone in the United States or the world maybe who has high blood pressure. A sample is a subgroup or a subset of a population that is hopefully representative of the population. So for example, all college students in the US, a sample might be 200 college students were surveyed to find their opinions on coronavirus policy, something like that. The sample would be the 200 college students who were surveyed. All right, so we're going to cover 4 different types of samples. All right, 4 sampling methods, if you want to call it that. In order to obtain a random sample, the first type, each subject of the population must have an equal chance of being selected. The best way to obtain a random sample is to use a list of random numbers. Okay, a systematic sample is taken by numbering each member of the population and then selecting every kth member, where k is a natural number. For example, the researcher from gradeinflation.com might have numbered all of the colleges willing to release grade information, right? And then chosen every 10th one to be part of his sample. In a stratified sample, a population is divided into groups where the members of each group have similar characteristics, like large public schools, large private schools, small public schools, whatever. And then members from each group are chosen at random. Another example of a stratified sample would be, you've got a medicine, say, that you want to test. And so what you do is you break people into different types of groups that you think might have different responses to your medicine. Maybe you break people by age group and by gender and by ethnicity or something like that. And then what you do is you decide, you know what, I want, say, 10 people from each group, and then you randomly pick 10 people from each group that you defined. Okay, in a stratified sample, you define groups, and then you randomly pick within each group to make sure each group is represented in your sample. In a cluster sample, an existing group or groups of subjects that represent the population is used for a sample. For example, an inspector may select at random 1 carton of calculators from a large shipment and examine each one to determine how many are defective. So you see this in the cluster sample, you pick a group that the group itself is representative of the population you want to study, and then you sample every single one in the group. Whereas in a stratified sample, you break the population into groups of the different types that you think might be important to know about, and then you randomly sample each group. Okay? All right. So, a couple more terms here. Statistical techniques used to describe data are called descriptive statistics. All right. Most of the stuff that we're going to do here in chapter 11, really everything we're going to do in chapter 11 is descriptive statistics. Some of it towards the end can also be used for inferential. Statistical techniques used to make inferences are called inferential statistics, right? So you remember from up here, an inference is a conclusion reached on the basis of evidence, okay? So inferential statistics is about studying data and making decisions about things based on evidence, whereas descriptive statistics is describing the data, organizing things, reporting it. You kind of think of it as step one and step two. The first step, you've got the data, you've got to organize it, report on it, figure out what you're looking at, right? And then you can figure out what you can decide about it, and you can apply inferential statistics. For example, an inferential example, the Bureau of Labor Statistics estimates the number of people in the United States that are unemployed every month. There's just no way they can survey every person in the workforce every month. So the Bureau picks a sample of adults to see what percentage is unemployed. All right, and then from the sample, they release a report that estimates the number of unemployed in the whole country. That's inferential. Going from the data in the sample to make a judgment call about the population as a whole. All right, so that's the end of our basic definitions. If you want to see more, about them, there's a link to the book in the Connect Math software. You've also got some of the videos there. Now we're going to move into the 3 types of problems, right? There's questions. In a sense, they're homework problems are really about the definitions, but they'll ask you for the definition, or they'll ask you a question that knowing the definition will enable you to answer the question, okay?